The constellation once known as Argo Navis represents the ship that Jason, a famous Greek hero, and his comrades the Argonauts, used on their quest across the Black Sea in search of the Golden Fleece. Astronomers later broke up the constellation of Argo Navis into 3 separate constellations, Carina, Puppis, and Vela, with Canopus assigned to Carina. Some sources suggest that Canopus was named by the Trojan war hero Menelaus during his journey in Egypt. When Menelaus and his men arrived in Egypt, his navigator, Canopus, was bitten by a snake and died not much after. Menelaus dedicated a port to him and named a rising star on the horizon after his fallen comrade. However, Canopus, being the second brightest star in the night sky, has more significance apart from just Greek mythology. In China, the star appears low in the southern sky, so Canopus became associated with the Old Man of the South Pole, one of the 3 stellar gods. The star is a symbol of longevity and happiness for both China and Japan. Polynesians knew it as Atutuahi and used the star to navigate long voyages in the ocean. Canopus, also known as Alpha Carina, is 310 light-years away from Earth, much, much farther than the Sun, which is only 8.3 light-minutes away. It is located in the edge of the southern constellation of Carina. To see the star, you must be in the southern hemisphere, or below a latitude of 37 degrees north of the northern hemisphere. Canopus will be seen below Sirius, near the horizon. This star has an absolute magnitude of negative 5.71. Absolute magnitude is a measure of a star's luminosity regardless of the star's actual distance from Earth. It is measured like apparent magnitude if the star in question was 10 parsecs away from the Earth. Apparent magnitude, on the other hand, is how bright a star appears to an observer, and the apparent magnitude of Canopus is negative 0.74. We can compare this to the Sun's absolute magnitude, which is 4.83, and its apparent magnitude, which is negative 26.74. Scientists haven't detected any Doppler shifts in the star's spectral lines, so they have labeled Canopus as a single star. This tells us that the star does not share a common center of gravity with any other star. Canopus is a white supergiant with a spectral classification of A9. The classification of A means the star has just the right temperature to put electrons into hydrogen's second energy level, which results in strong absorption lines becoming visible. The number 9 means that the star is one of the coolest in the classification system. In contrast with the Sun, which is a G2V classification, G2 standing for the second hottest star in the yellow G class, and V representing the star's dwarf classification. Canopus has a mass of 1.6 times 10 to the 31st power kilograms. But how do we know this? Well, astronomers can easily measure the mass of binary stars, which are 2 stars orbiting a common center of gravity. First, they must know the 7 major axes, or the mean distance between the 2 stars. Then they must find the time it takes for the stars to revolve around one another. Using only these 2 observations, astronomers are able to calculate the mass of those stars. For stars that are not in star systems, such as Canopus, the answer still lies in binary star systems. After calculating the mass of many stars in binary systems, as well as finding out how luminous they are, astronomers noticed there was a relationship between a star's mass and its luminosity. Therefore, for single stars, we only need to measure their luminosity and then simply use the mass-luminosity relation to find their mass. Speaking of luminosity, Canopus has a solar luminosity of 10,700, meaning its luminosity is 10,700 times greater than that of our Sun's. Luminosity is calculated by multiplying the star's brightness, which can easily be measured using a photometer, by 4 pi, and then the star's distance from the Earth. This bright star has a radius of 49,700,000 kilometers. The radius of any star is measured by knowing its luminosity and surface temperature. Knowing these 2 factors, all that's left is to rearrange the formula to solve for the radius. Once the formula is rearranged, plug in the values for luminosity and temperature, and solve for the radius. Due to their great mass, supergiants like Canopus are expected to live only around 30 million years, in comparison with the Sun, which is a main sequence star, and is thought to live for about 4 to 10 billion years. A star's life cycle is determined by its mass. The larger the mass, the shorter the lifespan. It's a bit unclear, but various models indicate that Canopus is anywhere from 24 million to 34 million years old, meaning it's nearly at the end of its life. Determining a star's age is a difficult task. Scientists sometimes look at the changes in a star's rotation speed to get an estimate for its age. Stars will begin to spin slower the older they are, like a spinning top on a table. Let's suppose there was a planet orbiting Canopus that could sustain life, like the planet Arrakis in Frank Herbert's novel Dune. How could we communicate to this new world? Well, when communicating with spacecraft at the moon and beyond, NASA turns to the Deep Space Network, NASA's international array of giant radio antennas used for deep space communication. Now, this is used for distances much shorter than Canopus, but in the years to come, as technology keeps improving, NASA might be able to create a satellite with enough reach to transmit signals to a planet orbiting Canopus. The antennas for these satellites would have to be extremely long, and scientists would have to find the perfect frequency to be able to communicate via the satellite. If we were able to communicate with the intelligent life on that planet, we probably wouldn't want them to know all of humanity's faults right away. We might want to skip over the history of world wars and ongoing worldwide violence as well as political disputes. I would want our civilization to be seen as intelligent and peaceful beings, especially since we wouldn't know the foreign people's tendencies at first. It's best to promote friendly alliances from the beginning, rather than risk an intergalactic war with beings that could potentially and probably be far more advanced than us.